A framework to define the measure electric parameter during EDM. Operations directly enter electrode value with an oscilloscopic external to the machines has been recently proposed by Ferry et al. This would be enable the user to estimate directly the electric parameter that affect their operation without relying upon the machine manufacturing claim. EDM power control. When using RC generator, voltage pulses shown in figure are responsible for material removal. A series voltage pulses of magnitude about 20 to 120 volt and a frequency on the order of 5 Hz is applied between the two electrodes. First one is a voltage, charging time, discharging time, 1 cycle, discharge voltage and time, variation of voltage with the time using RC generator. Next one is a EDM power control circuits. The first current, on time, off time. On time and off time is called as 1 cycle. The above line is called as peak current, this is average current. Typical EDM pulse current train for controlled pulse generator. EDM power control, the volt ionizations are in this area, one between the 1 cycle, on time, off time. This line is ionization. The end of line is called as breakdown voltage. This is called as a spark voltage. The line formed from this two, 1 cycle between on and off time. Again its rise ionizations, breakdown voltage, spark plug and time. This is a ionizations delay. The current, spark energy per unit produced inside, peak current, average current, time, voltage and current waveform during EDM. The voltage, current, charging time in between areas, current time, useful eruptions time, discharging time and final time. This is a periodic discharge in RC generator. Electrode material should be such that it would not undergo much tool wear when it is impinged by positive ion. Thus, the localized temperature rise has to be less by properly choosing its properties, or even when the temperature increases, there would be less melting. Further, the tool should be easily workable, as intricate shaped geometric features are missing in EDM. The basic characteristics of electrode materials are high electrically conductivity, electron are cold emitted more easily, and there is less bulk electrical heating. High thermal conductivity for the same heat load, the local temperatures rise would be less due to faster or heat conducted to the bulk of the tool and thus less tool wear. Electrode vehicles, high density for less tool wear and thus less dimensional loss or inaccuracy of tool. High melting point leads to less tool wear due to less tool material melting for same heat load. Easily manufacturability, cost and cheap. The following are different electrode material which are usually common in the industries. Graphite, electrolyte oxygen, free copper, tellurium copper 99%, Cu plus 0.5 tellurium basis, brass.